Ladies and gentlemen, it's time for our next talk. Give a big hand to Markus Kett from MicroStream.
Thank you so much, and thanks for joining my talk. This talk is all about caching, and it's not how you can earn money. So we want to accelerate and speed up our Java applications. And I like to show you in this talk how you can build the fastest database application with Java. So first of all, who of you is a database developer? Okay, some of you. All the other people, do you deal with data in your applications? Okay. Later, please. Good question. So who of you is using Hibernate? All right, nice. Who likes Hibernate? Okay, interesting. Who uses NoSQL databases? Okay, very interesting. All right, so as I mentioned, I like to show you how to build the ultra fastest database application with pure Java in this talk. And about myself, my name is Markus. I work for MicroStream, which is a database open source company located in Bavaria, Germany. So we are close to Munich, where the biggest beer fest globally is. So you're invited to come in October. So we are involved in several open source projects. We are very active in the Java community. We are a member of the Micronaut Foundation and the Eclipse Foundation, and contribute to several open source projects. We're part of, with our framework, part of Halidon, so we contribute also to project Halidon. So, and we have been working on database tools for the Eclipse development environment for more than 15 years or so. So we worked on the JBoss Hibernate tools to improve the JBoss Hibernate tools for Eclipse for a long time. And this is about my background, and this talk is about my personal experience in terms of database programming. And so we all have different experience. So, and this approach is not for everybody. It's really only for the hard people. So let's have a look in the reality. Data processing today, mostly our database applications are too slow. So actually we want to have high performance, but mostly database applications are too slow. So who of you has database application that is a little bit too slow and you have performance issues? Okay, someone. So, managers want to save data storage costs in the cloud, but mostly data storage costs are too high. Who of you believes your data storage costs in the cloud are too high? Okay, great. So, complexity, mostly in Java we love low complexity, but in database programming mostly complexity is very high. And also these days we talk a lot about sustainability. So we love sustainability, so it's very important for managers. So let's talk about the challenges first in database programming. So here are some, of course, basics, but very important in terms of caching. So this is the database server concept. So we have a Java application. Everything is fine. Everything's great because it's Java. Everything that is executed in memory, built with Java, is very fast. And then we have a database system. And when we have a look inside a database server, then we can see, okay, there is storage, of course. We have a database server. We need a lot of computing power. We need a lot of memory. The more memory, the better, of course. Then we have a database management system, and sometimes we have a lot of code. So business logic, stored procedures, stored functions. Who of you guys uses stored procedures? Okay, so not too much. So because we love Java, we write business logic in Java, of course. Okay, this is interesting. So nothing new actually, but important for later. So where are the challenges? So challenges in my perspective is we love Java. Everything is object-oriented, type-safe, great. As soon as we want to store data, we use a database system, mostly maybe a relational database system. Who of you uses relational database systems? All right, yeah, interesting. So relational database systems are completely different systems. They are incompatible with Java from the technical perspective. So because it is not possible to store your Java objects seamlessly in a relational database, right? Impossible. We're in trouble. Why? It's because the data structure is completely different. You cannot execute Java inside a database. So it's a completely different system. And so we have some mismatches here. But with NoSQL databases, it's pretty much the same. So the NoSQL databases introduce new data structure, completely new concepts like key value stores, document stores with JSON, or column-oriented databases. We have the graph databases, the object-oriented database invented in the 1990s. All of these databases, from a technical perspective, are incompatible with the Java object model as well. So we have pretty much the same challenges here. And so this might be a problem. But obviously, we use a lot of databases. There are more than 350 databases on the market. It should be solved, so in any way, of course. And of course, it is solved. So with relational databases, so last talk was about JPA, Jakarta persistence. So we have object relational mapping frameworks that do the job for us. So that's great because they tell us, hey, you can store your objects now in a relational database. Great. So we add object relational mapping framework like Hibernate. So, and now we can store objects, and behind the scenes, it generates SQL code, and vice versa, when we get data back from a database, it creates objects for us. That's great. The problem here might be it's not so fast. So the problem is the performance goes down because of the object relational mapping. Have you ever measured how long does it take to generate objects? So we did some performance tests, and mostly it takes milliseconds. So in practice, very often it doubles your query time. So even if your database is in-memory database and it's really fast, if you have an object relational mapping in between, you will have milliseconds. So so this is huge latency and very expensive. So, but of course, we can now accelerate our Hibernate queries, our JPA queries, by adding a cache. So the concept is memory is extremely faster than a database system. So it's around 1000x faster because, or sometimes up to 10,000 times faster because we have access directly to memory. That's great. So we store a result set directly in memory, and so we can avoid hitting the database. The challenge here is we add a cache, and we add also complexity to our application, to our code, because now you have to deal with cache configuration, and this is really a source of errors. So you have to be careful with cache configuration. All right. So here we have an architecture of a distributed system. So who of you develops distributed systems? Okay, great. So what's the challenge with a distributed system? So if data is changed on one of your nodes, that's great. Then this node will be in sync with the database. The problem is all the other nodes are not in sync with your database anymore. So now you can define some timeouts for your cache. There are different solutions how you can solve this problem. Maybe we use a distributed cache. So put the cache between your application and the database. So who of you guys uses a distributed cache like that? Okay, some of you. Okay, like Redis, Hazelcast, something like that. So, but the challenge is we add another complexity here. Maybe we have a lot of load on our database. We need some high availability for our database server. Then maybe we have another complexity here because we want to shard our database, or we need replication. So maybe we use a database cluster. So you can see our system gets more and more complex. So we very often on conferences, of course, talk about microservices because it's super popular stuff. So now we have some microservices and we scale our services. So you have multiple micro distributed applications. So you can see the complexity increases. And who of you is really a database fan? So nothing is better than a database system. Come on. Okay, great. So not so much, so not so many. Okay, interesting. There are some interesting solutions on the market just for searching, like Elasticsearch. Who of you uses Elasticsearch? I ask a lot of questions, I know. Thank you. So why are you using Elasticsearch? I mean, you have a great database. This is an answer for another talk. Yeah, so maybe searching is not so fast with a relational database. You have a lot of joins, and joins are very expensive. Maybe a searching server might be faster. Great. If it works for your use case, yeah, you should use it. Then you can see we add another data solution, and our infrastructure gets more and more complex. And the manager asks you, why are our cloud costs skyrocketing? I mean, here's the answer. And it's just because of we want to store some data initially. Isn't it crazy? Yeah, I mean, this is normal. This is standard. I know. But the question is, could we do it better, more efficient? Is there a solution? And the answer is, yes, it is. It's because of there's a pure Java solution, and this, of course, is not the solution for everybody, for all use cases, but check it out. I will show you now how you can do it more efficient and extremely fast with pure Java. So data processing with pure Java. Why pure Java? I mean, if you execute a Java program in memory, it will be fast, extremely fast. To get access to memory directly, this is it will take sometimes microseconds or even nanoseconds. So nanoseconds means this is a million times faster than milliseconds than access to a database. So Java is extremely fast, and because of our JIT compiler, it's really built for high performance computing. And we have a great data structure. All these databases on the market, they introduce their database-specific data structure or format. Why? Because they are built for a specific use case. So graph databases are great for complex structure and complex data, but maybe it does not work great for sensor data. Then you have maybe a time series database, but time series database maybe does not work great if you have complex data. In Java, we have objects, we have the object model, we can deal with single values, we can deal with lists, we can build very complex object graphs in the memory with circular references, so super complex data structure. We can deal with vectors. Everything is possible in Java. So we have already the perfect data structure. And in Java, we have a great query language. We have the Java Streams API. with the Java Streams API, you can search and filter in memory, and this will mostly take only some microseconds. So if you, for instance, you have 1 terabyte memory, and you push your data in memory and search and filter on a very complex object graph, it will take only microseconds, mostly. Even really complex filtering. So this is incredibly fast. And we also can save a lot of database or storage costs in our infrastructure if we don't use a database system anymore, when we just use a kind like blob store. So here is an example. Maybe the prices are not current prices, but it's an example. If you use a PostgreSQL database service on AWS, for instance, 1 terabyte, 2 CPUs, 8 gigabyte memory, it will cost around $4,500 depending on the region, and it's pretty much the same with other providers. So for 1 node, if you use more nodes, of course, your price will double, triple, and so on. The cloud providers also provide the binary data storages like AWS S3, so blob store. And the cool thing here is 1 terabyte AWS S3 costs only $300 per year. And it's more than 90% cheaper than a database as a service. I know there is, you have to add traffic here, but this is without traffic in both cases, okay? So now the question is, could we combine the power of Java, the speed of Java, with the cloud object storage? And this is possible. The only thing missing in Java is persistence. So there is no persistence, no native persistence in Java. And with the Eclipse Store project, we have now added persistence to Java. It is an Eclipse project, which means it's open source, it's under EPL license, so you can use it for free, also for commercial purposes. And I'd like to show you how this works and how fast it is. So Eclipse Store is a persistence framework, a persistence engine, similar to Hibernate, but completely different. Sounds crazy. So it's similar because it stores your objects. It's completely different because it does not store your objects in a relational database. It stores your objects everywhere, in any binary data storage, plain files or a blob store, by just serializing your objects directly to disk. So, and you can store the whole object graph, but mostly subgraphs are stored, and vice versa, it restores your object graph in memory when the object references are loaded. So it provides also lazy loading, so you can just load some data in memory that are hot, that are needed and required, and by using lazy loading and loading subgraphs when needed. But that's it. And with this solution, in combination with the core Java features, provides you a very powerful solution. And this is incredibly fast. Now I like to show you a small performance demo. Just a second, please. All right, here we can see 2 applications are running in parallel. It's a bookstore demo. The code is on GitHub. You can check this out. We have around 250 gigabyte data. One application is built with PostgreSQL, uses Hibernate, Spring Data, and EH Cache. So the standard, kind of like standard stack for relational databases in Java. The other application is built with core Java and with Eclipse Store as a persistence. So both applications keep data in memory, which means now we have access directly to memory. So we read data directly from EH cache. There is no hitting the database. And it shows every single query with core Java, with Java Streams API, is around 10 to 1000x faster than a comparable JPA query. You can really check this out. You can implement your own queries, try to beat it. This is really core Java stuff and shows how fast Java is. And we just added persistence and enable to store data persistently on disk. So it shows it's really incredibly fast. And you can do this and can achieve this with really core Java stuff. And can use it for any purpose and for your Java applications. To use it is really simple. It is just a Java library. You just have to add a Maven dependency, and that's it. You will find also the code on GitHub of the whole Eclipse Store project. So how does it work, basically? So here we have our memory, and the only thing you need is an instance of an Eclipse Store database, in-memory database. We need a root object, and it's a little bit similar to a J tree, a Java Swing tree. Who of you grew up with Java Swing programming? Ah, that's great. Nice. So it's similar to a Java Swing tree. And now you can add some objects here, and all objects that are reachable from this root object can be stored persistently on disk. That's it. That's super easy. And you have to create a data storage. So now let's add some objects here, and when we want to store an object, we just have to call one store method. That's it. And then a binary representation of your object will be created and stored in a file storage. So it's a binary file. And we use the Eclipse serializer for storing data. It's not the Java serialization. It's because of the Eclipse serializer enables you to deal with complex objects, any Java types. The depth of your object graph is not limited. So you can build whatever you like in Java. And it can store it on disk. And it's way faster than the Java serialization, and it's more secure than the Java serialization. This is the reason why we use the Eclipse serializer. So we store more and more objects, and we add more and more objects to our file storage. This is how it basically works. So very easy and straightforward. So this is a panned log strategy. Just one store method, and this operation is a transaction safe. It's a blocking operation, and it's ACID transaction safe, full consistent. So we have a transaction log, and it guarantees that data is really stored on disk. Concurrency. With Eclipse Store, you keep data in memory, you build an object graph in memory, which means all users operate on one and the same object graph. This might be challenging for some developers because of, wow, now I have to deal with concurrency. Who of you loves concurrency programming? I know a lot of people. Raise your hands. No one. Come on. Thank you. So, challenging, maybe. So this is the reason why now in the latest version we added a new logging API that simplifies dealing with concurrency, and it's pretty much the same like transactions in database. So it simplifies concurrency handling on your object graph. What happens if you shut down a system and you restart your system? That's also very easy. When you start your system, then Eclipse Store will load your object graph and your whole object graph in the memory, but no data. Only object IDs are loaded into memory. It's kind of like indexed object graph in memory. So, and then you just have to call get methods to load object references into memory. So there are no more classic selects. There's no more synthetic Java API to wrap SQL or something like that. Just call the common get methods. And if the objects are in memory already, you get it from the JVM. If not, then the Eclipse Store framework will load it, and you will get the object from the JVM. As I mentioned, we do not load the data, so you can define whether you want to preload some data or everything should be lazy, then no data are loaded initially into memory. When you call get method, then the object references are loaded into memory and merged directly in your object graph. So you don't have to deal with object copies. You can do that, so it has also advantages to use object copies, but you don't have to do that. So framework merges your objects directly in the object graph. This is how it works. So also code is very, very simple, very easy to use. Searching and filtering, I mentioned already, we use just Java Streams API for searching and filtering data in memory. Now, the question is, mostly, do I have to load the whole database in the memory because for searching and filtering with Java Streams, I need all my data in memory? Yeah, you can do that. It's recommended. If you have a lot of memory, you can do that. But it's not mandatory. You can have 100 gigabyte database and only 4 gigabyte memory. It will work. So we provide pageable collections. We provide indexing. So there are various concepts to deal with big amount of data and bigger lazy references. So schema evolution or schema changes. So if your classes change, this is not a big deal here with this concept. When Eclipse Store loads an object in the memory, it will compare your object with your class. If you have changed your classes, you add a field, you remove a field, rename a field, change types. This can be solved by the framework automatically. For more complex cases, you can define a so-called legacy type mapping. And then you store your object again, append it to the file storage, and then you have two versions or a new version of your object in the file storage. And you as a developer, now you can decide whether you want to keep all the legacy objects, all the legacy versions, or let the framework remove the older versions, the older object versions from the file storage, which is done by a kind of like garbage collector for the file storage behind the scenes. So it removes older objects from your file storage. So you get a lot of stuff with the Eclipse Store. As I mentioned, the Eclipse serializer is the core of this project. Then we have an implementation for the JVM and the same implementation for Android. Who of you develops Android apps? It's not so popular at Java conferences, but it is possible. So if you have colleagues using Android, it's pretty much the same concept. And they have, on Android, we have the same challenges like on a server side. So there's also a framework like Hibernate. It's called Room. Then we have this so-called legacy type mapping for schema migration. The file system garbage collector, it's included, that cleans up your storage. The file system abstraction, so you can use it in all environments. You can use it also on Kubernetes, server-side, desktop, wherever Java runs. We have database connectors even, so you can store it on. You can store your objects in plain files. You can store it in blob stores, but you can also store your objects or serialize your objects directly into Kafka. And now the crazy thing is you can also store your objects again in relational databases. Why? It's because they can store binaries. And sometimes it is mandatory in organizations finally to use a database system. And maybe it fits great to your use case, and you want to use some features of your database like backup features or something like that, clustering maybe. There is a REST interface that enables you access to the file storage, and based on this REST interface, we have a graphical user interface where you can browse through the data. So it's an open system. You also, we have backup features, and we have also converter. You can import data, you can export data via CSV, for instance. And altogether, this is Eclipse Store. Everything is open source. As I mentioned, runs on a JVM, runs with all JVM languages. It even works with GraalVM native images. That's cool. It runs in all environments. The only requirement is Java version 11 or newer. So we have many database connectors, as mentioned. And of course, there are also some rules and challenges with this solution. Because it's a kind of like a paradigm shift in database programming. Why? Here we can see the database server concept. The database runs on a remote server, and you will query your database server. That's the common case. With Eclipse Store, this changes. So now your database runs inside your application. Your object graph becomes your in-memory database. There is no more remote server to query. So keep this in mind. This is just a storage, and this is how the serializer stores data internally on disk. Of course, we have some challenges here as well. It's built for Java, it's built for the JVM, so it is not built for any other programming languages so far. There are plans for porting this to .NET, but it's not interesting for this talk. It's built for Java developers, and very often Java developers love the concept because of many developers try to do this using serialization for storing objects 10 years before we started this concept. So maybe you will like it. It's a paradigm shift, so it's completely different. Maybe some people will not understand it instantly. There is no relational model anymore. So database admins mostly don't like it. It is not a drop-in replacement, so you cannot replace Hibernate with Eclipse Store. This will not work. Migrating is possible and is not too complicated. So many companies do it already. But as I mentioned, this is not just a drop-in replacement. There is no SQL support, and it's because of everything is object-oriented. It's built for Java, for the JVM, so there's no SQL support. If you have apps or services, third-party applications that get or need access to your data, then you can, of course, create, or you should create interfaces, and we do not let third-party applications get access directly to an Eclipse Store database, in-memory database. And actually, this is the way to do, the way to go. Otherwise, you take the risk that third-party applications change and destroy your data model. That's a different thing. The common database tools are not working because it's not a relational database, and so on. So, in terms of distributed system, this is just small information for people who want to build distributed applications. The open source framework is built for a single server solution, so works for a single JVM. There are some enterprise features. We introduce indexing and a fully automated lazy loading concept. This is part of an enterprise edition. But to be honest, we are talking about open sourcing even these features. And then there is a cluster solution available. It allows you to run distributed Eclipse Store applications on AWS based on Kubernetes. It's a SaaS service, and you can use it on-prem as well. So the only requirement here is Kubernetes. And this solution provides you replication, failover, data redundancy, all the important stuff you need for really big data applications. But in practice, so many people talk about distributed applications, but in most cases, you will be really great, really fine with just a single server Eclipse Store solution because it's so fast and so powerful. So you should check it out before you really think about using a cluster solution. So now how can you use it in practice? So there are users who want to replace an expensive database, need high performance. They use it really as a primary data storage. You can do that, and then you store a lot of database costs. But to be honest with you, most of our users don't want to replace their database system. So we have a lot of customers, they say, we have an enterprise database, it's super expensive, they charge us 10 million every single year, so actually we want to migrate. Finally, they don't. It's because of it is very important and so on. Then you can use Eclipse Store as a cache. So build a high-performance Java application that runs between your application and your database. And that's great, that works fine, and you can get out the most of Java with this concept. You can use it as a search server because it's more than a distributed cache. It cannot store just or keep data in memory. We have the Java streams for filtering, searching. We have indexing. You can combine it with all frameworks that are available in the Java ecosystem, like Apache Lucene for full text search. So use whatever it's available in Java. It fits great together. So you can build up very powerful search servers with Eclipse Store. You can use it as a custom tailored in-memory database for specific use cases. We have companies use it for online gaming, finance, high-frequency trading applications, logistics, so wherever you need best possible performance. And the cool thing is, when you use a traditional database and you really want to put business logic into the database because of it's closer to the data, it's faster executed, then mostly you have to use a database-specific language. You can do exactly the same with Eclipse Store, but it will be core Java. It will be plain Java. So you can do whatever you like and put business logic directly in your data layer and your caching layer. So it's awesome. Then finally, we have a distributed Java application where you only have one layer. You have the application and data inside one in the same node, one in the same JVM, and the cluster solution can replicate your object graph through multiple JVMs to multiple of your nodes. We have many customers using the concept for migrating their legacy stuff to microservices. So we build up in parallel a pure Java system that is ultra fast, and you can step by step migrate your your features, from your monolithic application, create microservices, more and more features, add more and more features to the system, create microservices, and you get out the best of the two worlds. So this is a great migration strategy as well. So conclusion, we have so many different approaches for database programming in Java. That's great. We have the Java Persistence, or Jakarta, now called Jakarta Persistence API. That's great. Works with relational databases. If NoSQL databases are a better approach for you, we have NoSQL databases. We have a very different caching frameworks on the market. Most of them, or they all mostly work as a key value store, so we have to deal with key value structure. Now we have Eclipse Store, which introduces or uses the plain Java object model, the original Java object model. You don't have to, there's no more mapping in between, no more data conversion to JSON. It's really your original Java object model. Build whatever you like. Any complexity, it can be stored and restored when needed. So you can build your, you can use it for a storage for your microservices, super cheap, very efficient, for caching, in-memory searching, yeah, so check it out. In our perspective, it will simplify database programming tremendously, because you deal with just core Java stuff, no more database-specific stuff, no more database-specific query languages and so on, no more Java APIs that wrap a query language, just core Java stuff. It's ultra fast, microsecond query time, microsecond response time, and yeah, this is great performance. Otherwise, you can wait for quantum computing. That's also a great approach. It will save you costs in a cloud, and all in all, more and more companies use it for building their high-frequency trading applications, or whatever they have to speed up. All right, so the code is available on Eclipse.io. No, sorry, the code is available on GitHub, but you can find more information on Eclipse Store.io. And as I mentioned, everything here is on Eclipse, is open source, Eclipse public license. Check it out, and maybe it helps you to speed up your application. Give us feedback. And I'd like to invite you also to rate my talk. If you don't rate it with fantastic, then I will come back next year with a sponsored session. Now, thank you very much for joining, and enjoy the party tonight. You can find more information or get more information at our booth, and have fun at JFocus. Thanks. See you next year. Bye-bye.